discuss some basic things, right? So relation and functions are two similar things, right? So relations means you create some existence of something or non-existence of something, right? So you find out the relation, right? Oh, maybe you are telling he is my cousin, right? That's a relationship, right, between you and that guy, right? So similarly, in mathematics, we have different relations, right? So if you have two numbers, then you can find out which one is the largest number. So this is a relation between these two numbers, 5 less than 8, right? This is a one relation, right? So likewise, not only this one, right? We discuss some set theories, right? So if you have two sets A and B, right? So maybe we are writing A is a subset of, sorry, uh, we can write A is a subset of B, right? So that's a relation, right? So the A is a subset of B. Some all the elements in A also exist in B. That is the meaning of these, right? So similarly, here relation means the important thing, you need two things, right? Two objects, right? So these two objects we can call a pair of objects, right? But the important thing, if it is a relation, the order of element is important, right? Order of elements. Order of the elements is mandatory, right? So if it is a relation, the order of the elements are mandatory, right? So if you have two objects A and B, right? So we can write this is a ordered pair, right? This is we can call ordered pair, right? The important thing, if it is a set theory, order of the elements, we didn't care about that, right? So let's say you have a set, it contain A, B, C, right? Set X contain three elements A, B, C. Similarly, you have a set Y, it contain B, A, C, right? So we can say X is equal to Y, right? We are not consider order of element in the set theory, but if you think about the relations, order of the element is mandatory, right? If you have a two elements A and B, right, it is not equal to if you have another pair of two objects B comma A, right? So this is totally different. A comma B and B comma A are two different pairs, two different things in the relations, right? So here, this is first element, right? Here, this is the first element, right? So order of the elements is mandatory in the relations, right? But not the case in set theory, right? So relation mean you need to remember, right? Always relation must be a ordered pair, right? So order of the element is mandatory, right? So if it is a relation, you need to remember, right? That is a ordered pair, right? So you need to remember if you are writing a relation, definitely it must be a ordered pair. So relation in the sense, we are considering the existence or non-existence of ordered pair between two elements or two objects, right? So if you have a two objects, A and B, right, you will check whether A and B have any connections between A and B, right? You have a ordered pair or you have a pair A comma B. So you need to check the relation between these two elements, right? Is there any connections between these two elements, two objects? We can say that is a relation, right? So the important thing you need to remember, relations are ordered pair, right? Always relations are ordered pair. The first thing you need to remember. Second thing, in relations, I already mentioned they are ordered pair, right? So A comma B is a one relation between A and B. It is not equal to B comma A. This is a totally different things, right? So this is first element, this is second element, right? This is first element, this is second element. That way we will arrange the ordered pairs, right? But not the case in set theories, right? Now we will look at the product sets, right? So already we learned set theory, right? We learned the basics of sets. So A is a set. Just imagine A is a set, three elements, right? B is another set with two elements, one and two, right? A is a set, three element. B is another set with two element. A is number of elements in A, three, number of elements in B, two element, right? So product set means product set means we can write product set as a cross B, right? If you have a two sets A and B, right? The ordered pair, right? So here A and B are two sets, right? The product set of A and B, we can write this way, right? We can read this one A cross B, right? We can read this one as A cross B, right? A cross B means that indicate this is a product set of A and B. A is a one set, B is another set. We will find out the product. Product means multiplication of elements in the ordered manner, right? So this is product set, right? So we can call this product set as a Cartesian product, right? We can say as a Cartesian product, or we can say as a product, right? All are correct, right? All are correct. A cross B means Cartesian product of A and B or product of A and B. We can call different names, right? So the A cross B means, right? The A cross B means, right? This is a ordered pair, right? So the product set means this is we can call A cross B, right? Like A cross B means you need to take one element from A, set A. Also, you take another element from B, then you are creating a pair, right? That pair A and B is a pair, right? This pair A, you are taking A is an element. A belongs to capital A. A belongs to set A, and B belongs to capital B, right? This way we are creating the A cross B, right? A cross B, we are creating this way, right? So here A contain three elements, B contain two elements. So if I ask you to write the A cross B, right? You need to take one element from A and you need to take another element from B, then you create an ordered pair. That way you can write all the possible number of pairs, right? That is called product set, right? So A cross B means you need to, A cross B means that's a product of sets, right? If you have A is a one set, B is another set. So you know A and B, what are the elements A and B have, right? So if I ask you to write the uh, A cross B, you need to write all the possible ordered pairs by using the elements of A and elements of B, right? So the first pair you can create, first you can take the element from A, right? So then first element from A, the second element from B. So A comma 1 is a one pair, right? Similarly, you are taking first element from A, then second element from B, right? A comma 2 is another pair. Similarly, B comma 1 is another pair. B comma 2 is another pair, right? Then C comma 3 is another pair. Then, sorry, C comma 3 is not coming, right? C comma 1 is another pair, right? Then C comma 2 is another pair, right? So altogether, how many pairs you created for A cross B? 1, 2, 3, 4, 5, 6 pairs, right? So 6 pairs you can create it by using the elements of A and B, right? So to find out how many pairs, so always we can't write all the uh, pairs, right? So let's imagine in the A, we have five elements. Let's imagine there is a set A. A contain five elements, right? Similarly, there is a set B. It contains eight elements, right? Then it's very difficult to write all the ordered pairs, right? Maybe you can write, right? So, but what we need to do without writing, we need to find out how many ordered pairs, right? We need to know how many ordered pairs we can create by using these A and B. How to do that? Just you can get the multiplication of number of A's, number of elements in A with number of elements in B. That is the only way we will find out how many elements in, how many ordered pairs in A cross B, right? So A contain 5 elements, 5 into 8, altogether 40 pairs we can create for this question, right? If you have a set with 5 elements, if you have another set B with 8 elements, then you can create 40 pairs, right? So why I am telling this A product B, product set of A cross B, right? A cross B is a product set, right? So here we are writing elements as a pairs, ordered pairs, right? This each pair we call as a relation, right? So here, just think about you are creating 40 pairs, right? From this 40 pairs, if you take few ordered pairs, that is we can call as a one relation, right? So here, just think about uh, yeah. Here in the previous case, A contain 3 elements, B contain 2 elements. So here we are creating 6 pairs, right? So here A cross B have 6 pairs, right? From these 6 pairs, we can create different relations, right? Uh, from these 6 pairs, we can create different relations, right? From these 6 pairs, we can create different relations, right? Now, we will discuss a little bit later the definition of relation. So relation means A is a set, A and B are two different sets, right? Relation is a subset of A cross B, right? Did you understand? Relation means that is a subset of A cross B, right? Someone asked something. Yeah, tell me why is we put A comma B, C is not coming. Yeah, I already told you, right? A cross B in the sense, right? A is a set, B is another set, right? So A cross B means you need to create ordered pairs with 2 elements, right? Did you get my point? You find out the relation, the cross product mean A cross B means you need to take one element from A, another element from B, right? Only you need to take one element from A, one element from B, right? We are not taking 2 elements from A or one element from B likewise, right? So ordered pair means that must have 2 elements, right? So we are consider the relation between only 2 elements, right? Not more than that. But your question is correct, but how it can possible, right? Let's say A is a set, uh, let's say A is a set A, B, C, B is a set uh, 1 and 2. Similarly, we have another set D. D contain 4 and 5, right? Now, if I ask you A cross B cross D, right? Then what will happen? Tell me. Now, each pair contain how many elements? 3 elements, right? This way. So here, A cross B means you need to take one element from A, one element from B, right? Here I am asking A cross B. Also, if I ask A cross B cross D, maybe you need to take one element from A, another element from B, another element from D, this way, right? So that's why here we are putting each and every pair with 2 elements, right? So if I ask you the cross product with A cross B cross D means, then what will happen? Here, A contain, first I need to take one element from A, another element from B, another element from D, right? So here 4. Similarly, A comma 1 comma 5. Similarly, then likewise it will write, right? So here A cross B, I am using only 2 sets, right? So that is we can call product of set. So not only we are taking for 2 sets, maybe n number of sets, it can be possible, right? Why we are look at here 2 sets? Relations we are consider only 2 elements, right? To find out the relation, we are using only 2 ordered pairs, right? Two objects as a one ordered pair, right? That's why we are only consider uh, A cross B, 2 sets with two sets, right? Okay, now just think about now, right? Now you are find out, now you are familiar with how to write A cross B, right? So if you have a set A with three elements, you have another set B with three elements, right? Now we can find out how many ordered pairs we can create for A cross B by multiplying the number of elements in A with number of elements in B. That is the way we will get the number of ordered pairs. So here 6 pairs we can create, right? So the definition says for the relation, you have a set A and B, right? From this set A and B, you can create relation by extracting some ordered pairs from the A cross B, right? So you have a two sets A and B, right? You can find out A cross B. A cross B have n number of elements, right? A cross B have 6 pairs here. By using sum of the 6 pairs, maybe not only six, all 6 pairs, we are creating relation with different elements from these 6 pairs, right? So it means relation is a subset of, so we can write relation is subset of A cross B, right? So just imagine A is a set, B is another set, right? We know A cross B, right? Depending on the number of elements in A and B, we can find out A cross B, right? So relation is a subset of A cross B, right? Relation means subset of A cross B, right? So for this scenario, okay, now I can create one relation R1, right, with A comma 1 and A comma 2. This is one relation, right? Someone create another relation, A comma 1, then B comma 1, then C comma 1, right? It's up to you. You can create different relation, right? Someone create another relation, A, sorry, A comma 1, B comma 2, then C comma 2. It's up to you. You are the one create relation, right? Now we need to find out how many relations we can create by using this A cross B. Is it possible? Now we need to find out how many relations, maximum of how many relations we can create by using this A cross B. How to do that? Tell me. By use the set theory, the knowledge of set theory, you can answer this question, right? So you have a set A with 3 elements, you have a set B with 2 elements, right? Now we know how to find out A cross B, right? So multiplication of number of elements in A and number of elements in B, we are getting all the ordered pairs, right? So here A cross B contains 6 pairs. Now my question is, we need to find out how many possible relations you can create for this A cross B. Maybe someone create another relation with one element. A comma 1 is a relation, right? Another guy create another relation with B comma 1. It's up to you. Can you tell me how many possible relations you can create for these? Someone tell answer. I need the equation. How to find out? How to find out how many relations you can create? So the equation, right? We know if you have a set, right? I already told you relation is a subset of A cross B, right? So you know the equation how to find out subsets, right? Just think about, you have a set X, right? It contains 3 elements, 1, 2, 3. So how many subsets you can create? We already discussed, right? So 2 to the power n. N is a number of elements. So 2 to the power 3, 8 subset, right? So 1 is a subset, 2 is a subset, 3 is a subset, 1 comma 2 is a subset, 1 and 3 is a subset, 2 and 3 is a subset, then 1, 2, 3 is a subset, empty set is a subset. So altogether 8, right? Similarly, you can apply here as well, right? Here what will happen? A cross B is a set now, right? A cross B is a set now. It have how many ordered pair? 1, 2, 3, 4, 5, 6 ordered pairs, right? So it means A cross B contains 6 elements, right? So a set with 6 elements, then how many subsets you can create? 6 to the power, if you have a 6 elements, 2 to the power n. So 2 to the power 6. How many? 2 into 2 into 2. 2 multiplied by 6 times. 8 into 8. 64 subsets, right? That is the answer. So it means 64 relations you can create by using the A cross B, right? Did you clear now? That is what I'm expecting from you, right? Is it clear to you? So altogether, from A cross B, you can create 64 relations, right? 64 relations you can create from these. Okay. Also the important thing, A cross B is totally different from B cross A, right? A cross B and B cross A are two different things. Why? In A cross B, the order of the element is mandatory, right? So here in A cross B, you are taking first element from A and second element from B, right? But if you think about B cross A, definitely you need to take first element from B, right? So first element from B, second element from A. So 1 comma A, then 1 comma B, then 1 comma C. Similarly, first element from B, 2 comma A, 2 comma B, 2 comma C. So altogether 6 pairs you can create for B cross A. Why I am telling here 1 comma A is totally different from A comma 1, right? So that's why we are telling A cross B is totally different from B cross A. Okay, if you look at here, R cross A, R cross R means R is a real number, right? So R means that is a real number, right? So real number means minus infinity to plus infinity. There is a undefined numbers available, right? Between minus infinity and plus infinity, we have real numbers, right? Okay, so R cross R means that is a huge set of pairs we can write. So real numbers, right? So that is a R cross R mean uh, product set of real numbers, right? So R cross R, we can write R squared, right? R squared or R cross R is equal the same meaning, right? So now I have a set A, right? Which have 4 elements, 1, 2, 3, 4, right? This is my question, right? Answer this question. You have a set A, right? That set contain 4 elements, right? Now A cube. So now I need how many elements, how many ordered pairs you can create for A cube, right? How many elements, how many ordered pairs you can create for A cube? How to do that? How many? So A cube means first you need to find out what is the A cube. A cube means A into A into A cross A cross A, right? Now we need to find out how many ordered pairs we can create. How to find out the answer? Just you can get the multiplication of number of element A into number of element in A into number of elements in A, right? So it means 4 into 4 into 4. So altogether how many? 64 ordered pairs you can create, right? So if it is A cross A cross A means it contain altogether 64 ordered pairs, right? I will write some few ordered pairs, right? 1, 1, 1. This is one pairs, right? Another pair, 1, 1, 2, right? Another pair, 1, 1, 3, right? Another pair, 1, 1, 4, right? Similarly, 1, 2, 1, right? Then 1, 2, 2, right? Then 1, 2, 3, right? Then 1, 2, 4, right? Similarly, for 1, 1, 3, 1, right? Then one pair. 1, 3, 2, another pair. 1, 3, 4, another pair. 1, 3, 3, 1, 3, 4, another pair. Likewise, you can write altogether 64 ordered pairs, right? So it's A cross A cross A means you can create 64 pairs, right? In the product of A cube, it has 64 pairs, right? Now tell me how many relations you can create. 2 to the power 64 number of relations you can create, right? So I need to answer this type of questions, right? So first thing you need to find out how many ordered pairs we can create. Then just you can apply the subset theory. Why I am applying subset theory? Relation is a subset of that particular A cross B or A cross C or something, right? So relation is a subset of the product sets, right? So then you can check how many elements in that A cross B or the product set. Then 2 to the power that number of subsets we can create. So it means 2 to the power that number of relations we can create, right? Okay, similarly here, right? A is a set with two elements, right? A is a set with two elements. Now I need to find out A cross A. Okay, now can you write the ordered pairs for A cross A? Right, A cross A means you have two A's here, right? So then what will happen? You need to take first element from this A, right? Maybe I'm taking this one and one. The second element from here. Similarly, 1 and 2. Similarly, 2, 1, 2, 2, right? Altogether, 4 ordered pairs we can create, right? So now tell me how many relations I can create. Number of relations, how many? So here 4 ordered pairs. So 2 to the power 4 relations, 2 to the power 4 subsets. So 16 subsets. So 16 relations I can write, right? 16 relations I can write. So, okay, I will write all the 16 relations if possible, right? Okay. First, we can create relation 1, right, with one ordered pair, 1, comma 1. This is one relation. Similarly, R2 with 1, comma 2, right? R3 is 2, comma 1. Similarly, R4 is 2, comma 2. So altogether here, 4 relations, right? Here, 4 relations, right? Again, I can write relation with two elements, right? And R5, 1, comma 1 and 1, comma 2. Similarly, R6, I can write 1, comma 1, then 2, comma 1, right? Similarly, sorry, R7, relation 7, 1, comma 1, 2, comma 2. This is another relation, right? R8 is R8, 1, comma 2 and 2, comma 1. Another relation, right? R9, 1, comma 2 and 2, comma 2. R10, 10th relation, 2, comma 1 and 2, comma 2, right? So 10 relations altogether with two elements, right? Then I can write with three elements, right? Relation 11, right? 1, 1, 1, 2, 2, 1, one relation. Then 1, 1, 1, 2, 2, 2, another relation, right? So 1, 1, 1, 2, 1, 1, 1, 2, 2, 1, one relation. R12, 1, 1, 1, 2, 2, 2, right? This is my 12th relation. Then I can write 13th relation, 1, 2, 2, 1, 2, 2, right? So altogether, you know how to write the subset, right? So one relation with four elements, another relation with empty element, right? 16th relation is without any elements, right? So that's an also a relation, right? Likewise, we can write the relations, right? Okay, now we will move for the next one. Yeah, this part we already discussed, right? Number of element in set A multiple by number of elements in set B. We can find out the how many ordered pairs we can create for that cross product, right? So this is all R cube means, that's also we discussed, right? So this diagram means, I think you already know that coordinate geometry, right? So you learn those things in your O levels, coordinate geometry, right? There are two axes, x-axis and y-axis, right? Here, if you have any point P, then they have a coordinate, right? They have an x coordinate as well as they have a y coordinate, right? So always we are right as an ordered pair, right? First is a x coordinate, second one is a y coordinate, while we are considered with the coordinate geometry, right? Whatever the point A or B or C, first we need to write the first coordinate as a x coordinate, then the second coordinate as a y coordinate, right? This is all the traditional way. This is a rules we can write. So this is also a ordered pair, right? So this is a relation between x coordinate and y coordinate, it indicating a particular point, right? Okay, now we will move for the relations, right? Already we discussed something, right? So now we will look at the definition of a relations, right? So if you look at the definition of a relation, right, I already told you, right? You have a two sets, A and B. A is a set. Also, you have a B is another set, right? So the relation with from A to B, right? There is a relation from A to B, right? Or relation we can call as a binary relation, right? Binary relations mean we are consider the relation between two objects. Binary numbers means two, the numbers based on two, right? The base is two. Binary means two, right? So binary relation we can call as a binary relation or relation. Both are same, right? So the relation, you have a two sets A and B. The relation from A to B, it means the relation from A to B is a subset of the relation from A to B is a subset of A cross B, right? You have a two sets, right? The relation from one set to another set. Just imagine you have a two sets X and Y. You have a two sets X and Y. The relation from X to Y is a subset of X cross Y, right? So this is the relation, right? So it means you have a two set, each set contains few number of elements, right? First, you need to find out A cross B or whatever the cross product of these two A and B. Then from this cross product of A cross B, you can take few elements, those few elements, few ordered pairs, we can tell as a one relation, right? So here you have a set A and B, right? First, you need to find out A cross B, right? In this A cross B, you have a n number of elements, n number of ordered pairs in this A cross B, right? From this n number of element ordered pairs in this A cross B, if you take few ordered pairs, then you can create a relation that is called relations, right? So that is the definition of a relations, right? Okay, just think about you have a set A with three elements A, B, C. You have another set B with the same one and two, right? Now the relation from A to B means first you need to find out the A cross B, right? So you can find out A cross B. It means six elements, right? A1, then A2, then then B1, B2, C1, C2, altogether six ordered pairs in the A cross B, right? Now relation means relation is a subset of A cross B, right? So A cross B, if you think about a set, if you create some subset from A cross B, these each subsets we can call as a relation, right? Did you clear? Any doubts? So that is we can call relations, right? So the important thing here, while you are creating these ordered pairs, right, that is important. If it is A cross B, definitely you need to take the first element from set A and the second element B, you need to take from B, right? So the first element A belongs to A, second element B belongs to B, right? That is important, right? Order is important in the relation, right? Yes, right. So if you find out few number of ordered pairs from A cross B, that is a relation, right? Okay, now just think about this one, right? Okay, just now think about, right? Okay, I already told you relation is a subset of A cross B. Now I am creating a relation R1, right? R1 with A comma 1, right? I am creating a relation with R1, A comma 1 and A comma 2, right? So this relation R1 contains two ordered pairs, A comma 1 and A comma 2, right? Now I can write this relation R1 this way, right? I can write this relation R1, A R1 1, right? Also, I can write A R1 2, right? So I can write this way. Also, I can write this way for this particular relation, right? What it says, right? What it says, A comma 1 is a element of relation R1, right? A comma 1 is an element of relation R1, right? So maybe I can read this one. Okay, I can read this one. A related to relation R1 B, right? A related to B, right? So this way I can write, right? Maybe I can read by using a symbol. This is a symbolic form, right? A R1 B, right? It means A related to relation R1 to B, right? A is related to B. A is related to B, right? Now, if you look at here, similarly, I can write A, sorry, A comma 2 is a element of relation R2, R1, R1, right? So A comma 2 is an ordered pair. It belongs to relation R1, right? So I can write this one, A related to relation R1 to B. A related to, sorry, this one also, A related to 1, right? Here I did a mistake, right? So first I am writing the first element, then I mention the relation symbol, then the second element. Here A, first I need to write the first element, then I need to write the relation R1, then I need to write the second element 2, right? So this way we can indicate, right? So now if you have a, just think about, right? You have A comma B is uh, A comma B belongs to relation R5. Just imagine, right? Now they are telling A comma B belongs to relation R5. Then you can write this one, A relation R5 related to B, right? This is, we are writing as a notation to indicate the relation. Now it says A related to B in relation R5, right? Now if I write this way, right? A comma, okay, now I'm telling B comma A is not belongs to the relation R6. It means what? It means in the relation R6, there is no any ordered pairs B comma 6, right? In the relation R6, there is no ordered pair B comma A, right? There is no relation B comma, there is no ordered pair B comma A in the relation R6. If you have a one relation R6, on that relation, there is no any ordered pair B comma A. Right? For this one, maybe we can write B R6, then you can cut down this way, cut down A, right? This is one way you can indicate the relation. This is another way you can indicate the not a relation. This is for relation. This is also for relation. These two ways you can indicate a relation with ordered pairs, right? So if you find out a relation, it is not mandatory. Always you need two sets, A and B, to find out a relation, right? Also, you have only one set. A is a one set with three elements, one, two, three, right? Then you can find out a relation by itself a relation, right? Itself a relation means, right? Itself a relation means what? You need to find out A cross A. If you find out a relation or binary relation from a set A itself, means first you need to find out A cross A. So can you tell me how many elements, how many ordered pairs in A cross A? 3 into 3, 9 elements, right? So what are they? 1, comma 1, 1, comma 2, 1, comma 3, then 2, comma 1, 2, comma 2, 2, comma 3, then 3, comma 1, 3, comma 2, then 3, comma 3. So altogether 9 ordered pairs, right? Altogether 9 ordered pairs for A cross B. Now we can write a relation by using sum of the ordered pairs from A cross A. This is we can call a relation by itself, right? Okay, now in the relation we have two terms, domain and range, right? Okay, now for this question, I am writing a relation R1, right? Writing a relation R1 with 1, comma 1, 2, comma 2, and 3, comma 3. Okay, rather than this one, right? I am telling a relation R1. R1 is both elements are R1 is a relation, right? I am telling a question. R1 is a relation that both elements are same elements. Okay, can you tell me what is the R1 relation contains? What are the pairs R1 relation contains? Hmm? Maybe if I ask this type of question, right? I am writing in the sentence form, right? R1 is a relation. Just look at for this scenario, right? So A is set with 1, 2, 3. Now we can find out A cross A. Right now I am telling a relation R1. R1 is a relation on A. R1 is a relation on set A that both elements are same elements. So it means what are the possibilities? What are the possible pairs coming? Both elements are same elements means so only three elements, 1, comma 1, 2, comma 2, 3, comma 3. So these are the three ordered pairs for relation R1, right? So now if I ask you what is the domain, what is the domain for this relation R1? Domain of relation R1, domain of relation R1. So domain means I need to write all the distinct first elements, right? All the distinct first elements we call as a domain. So one is a one element, two is another element, three is another element. So this is called domain of the relation R1, right? If you look at this type, okay, now another relation R2, right? They have 1, comma 1, 1, comma 2, okay, 2, comma 2, 3, comma 3. Right? Now if I ask you the domain of relation R2, can you tell me? Hmm. Is it correct? Someone right. So domain means the first element of the ordered pairs, right? Someone asked writing 1, comma 1, comma 2, comma 3. Is it correct? This one, 2, 2, right? So if I ask you to write the domain, if element duplicate, you don't need to write that again, right? So just you can write 1, comma 2, comma 3 is the domain of this relation, right? Even if you have it 2 times or 3 times, n time occurs, you need to write only 1 times, right? While you are writing in the domain of the relation. So domain means domain of a relation R is a set of all first elements, right? Of the ordered pairs, right? For a particular relation, we have n number of ordered pairs. No, for each ordered pairs, you need to take first element. Then we can say that is the domain of the relation. At that time, you need to check whether is there any duplicated values. Then you can remove the duplicated value. Only one time we will put the first element of the ordered pair, right? The next one, the range. Range means the second element of the particular relation, right? For the relation R1, range of R1. Now tell me what are the range of R1. So range of R1 means you need to take only the second element in the ordered pair. Right here, the range is 1, comma 2, comma 3. Right. Similarly, can you tell me here? So what is the range for R2? So range for R2. So the second element of relation R2 with the each ordered pair. So relation R2 have 4 ordered pairs. So the second element is, so here this one. One is a one ordered pair, two is an ordered pair. So again, two is happening. Can you write or not? We can't write duplicate values, right? So just only one time we can write two. Then the third ordered pair, second element is three. So 1, 2, 3 is the range, right? So even if you have a duplicated value, two times or more than two times, you cannot write only one time, right? So domain means the first element of the ordered pair in the relation, range in the sense the second element of the each ordered pairs in a relation, right? Any questions? Any questions? Any questions? Yeah, there is nothing, right? Just think about, right? You have a set A with three elements, A, B, C, right? So now I'm creating a relation R1 with the set A itself, right? So it means you have a set A, B, you have a set A with three elements, A, B, C, right? Now I am creating a relation R1 with set A itself. Set A itself means, right? I am creating a relation with A cross A, right? I am creating a product set with A cross A, right? Itself, I'm creating a relation with itself mean I'm using the same set twice, right? That is the meaning of I'm using a relation with the set itself mean I'm using the same set again and creating a relation, right? So you have three elements, then I can write the A cross A, right? Definitely it have 9 pairs, right? So now in these 9 pairs, right? I'm creating a relation R3. I'm creating a relation R3. It is definitely subset of A cross A, right? So I'm writing this R3 is a relation. R3 is a relation. Both elements are R3 is a relation. Both elements are same elements, right? So I'm writing here R3 is a relation. Both elements are same elements means what? So both are A, both are B, or both are C's, right? So now, right, R3 is a relation, right? It both elements are same elements, right? So R3, what are the possible ordered pairs coming? A, B, B, C, C, right? Now, if I ask you the range of, if I ask you the domain and range of these R3. So domain means in this relation, you need to check how many elements you have, right? So you have three elements, right? From these three elements, if you take first element in these three ordered pairs, you need to take first ordered element, first pair, first element of this each ordered pair, that is we can call as a domain, right? So in this first ordered pair, so the first element is A, right? In the second ordered pair, the first element is B, third ordered pair, first element is C. So ABC is the domain, right? Range in the sense you need to take the second element of this ordered pair, right? In a particular relation, you have three ordered pairs, no? So if you take second element of these three ordered pairs, we can take this one is the range, right? So at that time, domain and range, we cannot take the duplicate values. It means, let's say in the particular relation, you have another another ordered pair, right? A comma C is there, right? So now think about A, B, B, C, C, and A, C is also there, right? Now, domain means you need to take first element also. You are taking this one, this one, this one. You cannot take this A, right? Because already the A is available, right? So we can't remove the, we can't put the A again. We can remove the duplicate value. So also the domain is A, B, C. Similarly, for the range here, already we write this A, this B, this C, right? Also, here also we have a C, right? We can't write this C, right? Only unique values are in a set, in a range. So only A, B, C is the range, right? Any questions? So domain mean the first element of a relation, right? In a relation, you have in a few number of pairs, right? So if you take the first element of that ordered pair, that is a domain element. If you take the second element of that particular pair, that is a range, right? So now we will look at some examples, right? Okay, if you look at the first example, right, they are giving two pairs, two sets A and B. A contain three elements, one, two, three. B, here we need to put the curly brace, right, not the parentheses. So A is a set with three elements, one, two, three. B is a set with three elements, X, Y, Z. Now tell me, if I ask you to write the A cross B, how many elements, how many ordered pairs you have? How many ordered pairs in A cross B? Number of elements in A multiple by number of elements in B, right? 3 into 3, 9 ordered pairs, right? So if I write A cross B, they have 9 ordered pairs, right? It means 2 to the power 9 number of relations I can create by using this A cross A, right? Now they are telling, okay, in this question, right? So they are giving A and B, right? Now they are telling a relation, right? They are telling a relation, right? So here, if I write A cross B, then what will happen? 1x, right? 1y, 1z. Similarly, 2x, 2y, 2z. Similarly, 3x, 3y, 3z. So altogether 9 pairs, right? So relation means subset of this A cross B, right? So now they are telling a relation R, right? In this question, they are telling a relation for us, right? Definitely, in this relation R, each pair is a subset of this one, right? So it means each pair always exists in this particular uh, A cross B, right? If you look at here, 1 cross Y is this one, right? This 1 cross Z means this one, right? 3 comma y means this one, right? Definitely, whatever the relation, if you are creating by using a particular set A and B, that is must be a subset of A cross B, right? So here also this relation R also is a subset of A cross B, right? So this is a one relation. It means from this A cross B, they pick three ordered pairs and they are creating a relation. That is a one relation, but they are using that relation for some purposes, right? Now they are telling R is a relation from A to B, right? Since R is a subset of A cross B, right? They are telling R is a relation from A to B. That's the definition of a relation, right? Because uh, the ordered pairs in R is a subset of A cross B. A cross B subset is R. So R is a relation from A to B, right? Now we can write this relation, right? This relation R contain three ordered pairs, 1 and Y, 1 and Z, 3 and Y, right? These are the three ordered pairs, right? Now we can write this one this way, right? Maybe we can write 1 comma Y belongs to R. Similarly, we can write 1 comma Z belongs to the relation R, right? Similarly, we can write 3 comma Y belongs to R, right? This is one way we can write. Also, we can write this way, right? 1 related to Y. Similarly, we can write 1 related to z. Similarly, we can write tree related to y, right? Now, this relation R contain only three elements. Now tell me, how about 1 and x? How about 1 and x? The 1 and x is not a relation in R, right? So it means why I am telling here 1 comma x is not exist in the relation R. In the relation R, there is no ordered pair 1 comma x. Then I can write this one 1 comma x not belongs to relation R. In that relation R, 1 comma x not belongs to relation R. This is one way we can write. Another way we can write 1 not relation X, right? These are the different ways we can write to indicate a relation with their ordered pairs, right? So similarly, for all the remaining elements, we can write this way, right? It means 3 not related to Z. It means 3 comma Z is not belongs to relation R. That is the meaning of this one, right? So now tell me, what is the domain of this relation? Now this is a relation. No? So what is the domain? What is the domain of the relation? Domain means what? Already we know domain means you need to take first element of each ordered pair, right? So now here the first element is 1. So 1 is a 1 element. Here all another 1 is coming, right? But we can't write again. Duplicate values we can't write. So already 1 is exists. The third ordered pair have 3. So 1 comma 3 is the domain of this function R. Similarly, if I ask you the range, what is the range? So second element of each ordered pair. So y is a one range, z is a range, or another y is coming. So we can't write duplicate value. So y comma z is the range of this function, right? Okay. The next thing, yeah, this is a subset mark, right? So subset also a relation. They are telling subset is also a relation. They are telling different example for relations, right? So if you have a set A, while I am toss the dice, all the possible outcomes are considered as a set A, right? B is a set, odd number occurs, right? Odd numbers means 1, 3, 5 is the set B. Set A means 1 to 6. 1 to 6, we can say set A, set B, odd number occurs, right? Now we can write this is two ordered pairs, right? Then we can find out a relation, right? B is a subset of A, right? This is also a relation. They are telling this is also possible come as a relation, right? Similarly, another example for relations, right? There is a set. There is a set. Z is a set that is a integers, right? Z is a set of integers. So minus infinity to minus infinity, minus 3, minus 2, minus 1, not 1, 2, 3, plus infinity. This is the set. Set is a set, right? Then from this set, right, there is a relation they are telling, right? M divided by N, right? M is a element from this set, N also element from this set. We need to find out which M and N divides, which what are the possible values M can divide N without any reminder, right? So maybe just think about, I'm taking 10, M is 10, 10 divided by 2, then it is possible, right? Similarly, but if you look at 11 or 7 divided by 25, we cannot divide 7 divided by 25 without any reminder, right? So it means that is a decimal value, right? So if I divide 7 divided by 25, the value is 0.28, right? This is not an integer, right? So it is not possible. So 7 and 25 is not elements in that particular relation. That is they are telling here, right? Similarly for the parallel lines, right? If you think about the coordinate geometry, we can find out the parallel line, right? If it is a parallel line, slopes are same slopes, right? M slope is the equation for straight line, y is equal to mx plus c, right? So m is the slope, c is the place where it will meet the y-axis, right? So if you find out two parallel lines, they have same gradient, right? The m is the same value. We can say as a gradient, right? Tan theta, right? So if you similarly, you can do a relation between the parallel lines. So they are explaining this. These are some real examples of relations, right? Okay, now if you look at the E, let A be any set. An important relation on A is that of equality, right? So they are telling a relation, right? Just think about A is a set, right? Maybe A have some number of elements, right? A, B, C, D. Just imagine A is a set with 4 elements, A, B, C, D. Right now they are telling there is a relation on A. A itself, there is a relation, right? It means we need to think about the A cross A. First, you need to think about A cross A. Then in that relation, they are telling that the important thing here, equality, right? Both elements are equal. Equality means both elements are equal. Then can you tell me the possible elements for this relation? A comma A, B comma B, C comma C, and D comma D. These are the possible elements in that particular relation. Why they are mentioning as a equal relation, equality of the elements, right? So this is the only possible relation for these A, right? Okay. Now, if you find out A cross A, right? Then how many elements? 4 into 4 altogether 16 ordered pairs are coming, right? So this A cross A means that is a set, right? A cross A means, let's say in the previous case, let's say there is a set X with 3 elements, 1, 2, 3, right? Then the set X itself as a subset, right? We have a theory, empty set, and the set itself we can tell as a subset of that, right? So it means for A cross A, the A cross A also a subset, right? That's relation. A cross A means the relation R is a subset of A cross A, no? So if you find out a relation with all the elements of A cross A, then we can say that is a universal relation, right? The special name for that one, we can call that one as a universal relation, right? Similarly, if you write a subset of A cross A, empty set is a subset, right? So that relation with empty set, we can say that is a empty relation. So empty relation means the relation with empty set. Universal relation mean the relation with all the elements of A cross A, right? If you write a relation with A cross A, that is a universal relation, right? These are the things you need to remember, right? Now we will move for the inverse relation, right? Already we discussed inverse functions, right? Do you remember the inverse function? So what is the conditions to become an inverse function? Tell me. If a function is a 1 to 1, as well as if a function is a on to, then we can say that function have the invertible function. The inverse function also available. Only if the function is 1 to 1 and on to, then only we can say that function have an inverse function, right? So we already discussed f of x is equal to 2x minus 5. Then we can find out the f of inverse x. How we can find out the inverse x? So just y is equal to 2x minus 5. Then you can change the subject as a x, right? So y plus 5 is equal to 2x. So x is equal to y plus 5 divided by 2, right? So this is the inverse function of y, right? Inverse function of y is equal to y plus 5 by 2, right? So I need f of inverse x. So f of inverse x means x plus 5 divided by 2, right? This is the way we can find out inverse function, right? Similarly, the inverse function, now here we are look at the inverse relation, right? So these things we already discussed yesterday, right? Just revise the thing if you can't understand, right? So now we will move for the inverse function, right? Sorry, inverse relation, right? So inverse relation mean, let's think about R is a relation, right? Just there are two sets, A and B. A is a set. Similarly, B is another set, right? You have a relation R. So definitely that relation is a subset of A cross B, right? We know these things, right? So the inverse relation means R inverse. Inverse relation we can denoted by this letter R inverse. R to the power minus 1. That is the indication of inverse relations, right? So here the relation R means the relation R from A to B, right? From A to B, right? But the relation inverse relation means that is inverse relation from B to A, right? So here A to B means, right, you take the first element from set A and the second element from B, right? The inverse relation means the first element from B, second element from A, right? So previous case, the domain you are taking, domain elements are from A, codomain, the domain elements are from A, range from B, right? Now what will happen? The range, now the domain elements are from B, range elements are from A, right? Okay, just forget about these things, right? You have a set A, they have three elements, 1, 2, 3. Similarly, you have a set B with three elements, X, Y, Z, right? Now we we no we find out a relation, right, from A to B, right? R is a relation from A to B. Just think about R is a relation from A to B. They are telling 1 comma Y, 1 comma Z, and 3 comma Y, right? So this is a relation from A to B. Now they are asking, find out the, now they are asking, find out the relation, find out the relation from find out the relation from B to A. Or they sometimes they will ask find out the inverse relation of R. Find out the inverse relation of R. They will ask a question, find out the inverse relation of R. So how you can answer this question? Just you can find out the relation in inverse relation. We already know if you have a relation to find out the inverse relation, right? What will happen in the relation? You are taking the first element from A, second element from B, right? But if it is an inverse relation, first element from B, right? Now what will happen? Your first element from B, right? So what is the first element from B means this one. So your inverse relation y comma 1, z comma 1, and y comma 3. So this is your inverse relation, right? Just you can swap the elements, right? By if it is a relation you are taking from A to B, if it is an inverse relation, you are taking from B to A. So in that relation, first you can take the second element from B first, then you are taking the second element as a first element as a second element, right? Just swap the elements, that is the inverse relation, right? So you have a relation R, right? For that relation R, if you take inverse, again, if you take inverse, it will give the same relation, right? So what I'm telling here, you have a relation R, right? This is a relation R. If you take the inverse relation first time, if you take this inverse relation second time, it will give the same relation. Okay, just look at here. Now this is R inverse, right? If I take inverse of this R inverse, now what will happen? Just I can swap the elements, right? 1 comma Y, 1 comma Z, and 3 comma Y, right? Now just compare this R and R inverse of inverse, both are same, right? So R and R inverse of inverse are same. This is the definition, right? The R inverse of inverse, that comes R, right? So the domain and range of relation R consider as a codomain and range. It also swept in the inverse relation, right? Okay. Now we will look at the pictorial representation of relation, right? Now, this is the so now up to now we are writing the relation in the ordered pairs as a ordered pairs this way, right? Also, we can denote the relation as a pictorial representation. By using a graph, we can represent the relation, right? We will look at 2 or 3 different types of pictorial representation of relations, right? Okay, the first pictorial representation is directed graph, right? Directed graph means they are using arrows to indicate the uh, direction, right? Just look, okay, I will explain how to draw this directed graph for a relation, right? Now, if I give a relation by using this way, let's say I'm writing a relation, let's say A is a relation 1, 2, 3. A is a set 1, 2, 3. B is a set X, Y, Z, right? B is a set with X, Y, Z, right? Now I am writing a relation R here, right? 1 comma X, 1 comma Y, 2 comma Y, 3 comma Y, right? This is my relation, right? Just think about this is my relation, right? If I need to draw the directed graph for this one, okay, if I need to write a directed graph for this one, right, just I can plot what are the possible elements in the relation, right? One is there, so I can plot one, right? There, and also the X is there, right? Similarly here, Y is there, right? Also 2 is there, also 3 is there, right? Just I can put nodes, right? Each element I consider as a node, right? So it means each unique elements in that relation I am using with the node, right? One is an element as a node, another one is there. So even if I duplicate, I can write again and again, right? For each unique element, I am creating a node. This is one for not for one. This is not for two. This is not for three. Also, X is there, Y is there, right? Now, first thing, I need to take this ordered pair, right? I need to take this ordered pair, right? The first element from 1 to X, right? Just I can denote this way. This is the uh, directed graph, right? Then I take the second pair, right? Then 1 to Y. So this way, right? Then 2 to Y this way. Then 3 to Y, right? This is the directed graph of that particular relation I mentioned here, right? This is if you have a two sets A and B, right? This is the way we can denote by using a directed graph, right? Now, if you look at this example, this is also a set, right? This is also a relation, but for this relation, only have a set A, right? Now, in this question, they are telling a set A. A contain four elements, right? So they are telling a set A with four elements. 1, 2, 3, 4 are the elements of set A, right? Now, it create a relation with itself. A create a relation with itself, right? So it means here we are consider A cross A, right? Now in this set there are four elements, right? If you have a four elements, right, just you can plot these four elements. You don't need to worry about the order. Maybe just you can write whatever the order, 1, 2, 3, 4, 1, 2, whatever the order you can follow. Just you can create nodes for each element in the set, right? Now in the relation, first I need to check first ordered pair. 1 comma 2 is my first ordered pair. So my first element to second element, I draw a arrow, right? Second, 2 comma 2, right? 2 comma 2 means itself, it has a relation, right? So then I can use itself, right? Then 2 comma 4, so this way. Then the next one, 3 comma 2, so it will come 3 to 2. Then 3 comma 4, this way, right? Then 4 comma 1, this way. Then 4 comma 3, this way. So this is the directed graph of the relation they are giving, right? So the important thing, not each and everyone get the same diagram. Depending on the nodes you are creating, the order of the nodes you are getting a different diagram. I will look at here. I put this order 1, 2, 3, 4. Now what will happen? 1 to 2. So this way. So 1 to 2. 2 to 2 means this way. 2 to 4 this way. 3 to 2 this way. 3 to 4 this way. 4 to 1 this way. Then 4 to 3 this way. Likewise, it will change depending on the nodes you are creating, right? So this is one way we can pictorial representation of a relation, right? So the next representation, there are two different types of representation, function representation. I think you already know this one, right? Similar to the function representation. Also metric representation. There are another two different ways we can represent the relation, metric representation as well as function representation. Function representation, you're already familiar with that one, right? So if you look at for the same relation R here, right? If I now I am planning to pick functional representation, function graph representation, right? So if I function graph representation, I have a domain and codomain. So now tell me what are the elements come for the domain? Hmm? All the first elements are coming for my domain. Second elements are coming for my codomain, right? So the first elements are one is there, two is there likewise, right? So better way, right? I can write all the elements here. 1, 2, 3, 4. Here also 1, 2, 3, 4. Right? Then what will happen? Here 1 to 2 this way. Here 2 to 2 this way. Right? Then 2 to 2 to 4. Right? This is not a function, right? If it is a function, it is not possible two domain elements coming from the same, right? This is a similar to the functional notation. That's why we are putting 2 to 4, then 3 to 2, then 4 to 1, then 4 to 3. This is a diagram for functional graph representation, right? This is one way of representation. Another way of representation, metric representation. Metric representation means you are writing uh, columns as all the elements 1, 2, 3, 4. Also, you can write 1, 2, 3, 4 as a rows, right? From here, right, what will happen? We are using 0 and 1. 0 means there is nothing. There is no relation with that pair. 1 means they have relation with that pair. So 1 comma 2 means the first pair is 1 comma 2. So I'm thinking first element this one, second element this one, right? This is first element, this is second element. So first element 1 comma 2 means this is 1, right? Then 2 comma 2, 2 comma 2 means this one. Then 2 comma 4, 2 comma 4, this one. Then 3 comma 2, 3 comma first element 3, second element 2. So this one. Then 3 comma 4, this one. Then 4 comma 1, this one. 4 comma 3, this one. All the remaining elements are we are putting 0, right? Here 0, 0, 0, 0, 0, 0. That's nothing, right? You have consider as a rows and column. If we have any ordered pair on that relation, just put 1 for that one. If there is no relation, then you have put 0 because here 1 comma 1 is not there in the relation. That's why 1 comma 1 is not there in the relation. That's why I'm putting 0 here. If you look at here, 4 comma 4 is not there in the relation. There is no 4 comma 4. That's why I'm putting 0 here. Likewise, altogether three different ways: directed graph, functional diagram, as well as metric representation. These are the three different representation of relations. Okay. Now they are giving two sets, right? A and B, right? Okay. Okay. Now they are considered this, right? Now we will look at this A 1, 2, 3, B X, Y, Z, right? So by using these, we try to plot these two, right? So A is 1, 2, 3, B is X, Y, Z, right? So these are the two sets. Two sets. A is a set with 1, 2, 3. B is a set with X, Y, Z, right? There is a relation. They are telling that there is a relation from A to B. Relation is from A to B, right? So it means we are considering A cross B, right? Now, okay. Okay. This one is the relation, right? Just think about this is the relation, right? This is the relation they are telling. Now we need to plot the matrix diagram as well as the uh, functional graph, right? So first we will look at the matrix diagram, right? For the matrix diagram, right? Maybe I will take the columns. Maybe I am take the column as a 1, 2, 3 or X, Y, Z. Okay, now for whatever you can take, right? It's up to your decision. Right now I am taking X, Y, Z is my uh, okay. B is my columns, A is my rows, right? So A contain what are the elements? 1, 2, 3 is the elements of A. Uh, elements of B, X, Y, Z, right? So the first element says 1 comma Y, right? So 1 comma Y. So I am putting 1 here. Second one, 1 comma Z. Third one, 3 comma Y. So these three, only three ordered pairs are there. So the remaining thing I am putting 0, 0, right? So this is the matrix diagram, right? Just nothing, right? So similarly, if it is a functional diagram, right, I am taking A first, right? So it is a function from A to B, no? So this is A, this is B. So A contain 1, 2, 3, B contain X, Y, Z, right? The first ordered pair 1 comma Y. So this one. Second ordered pair 1 comma Z. Third ordered pair 3 comma, sorry, 3 comma Y, right? This is the functional graph representation of a relation. This is not a function actually, right? Functional type of representation, not exactly a function. That is a relation, no? So relation, we are using these type of different pictorial representation, right? Okay, the next thing, give me another 20 minutes. I will try to finish, right? Okay, the next is composition of a relation, right? This is also, we already discussed composition of a function, right? Let's say a function from A to B, another function g of x from B to C, then we can write g of f is equal to A to C. This is function in the function we discussed, right? Similarly, we have composition of a relation, right? Composition of a relation means, just think about, you have a three sets, three different sets, right? Three different set. A is A, B, C. You have three different set A, B, C, right? You have three different set A, B, C, right? You have a relation R, you have a relation R, you have a relation R between A and B. So A is a relation, sorry, R is a relation between A and B. So it is a subset of A cross B, right? There is another relation S that is a subset of B cross C, right? There is a relation R from A to B, also another relation S from B to C. Then we can find out a relation, the composition relation R of S, right? Previous case, function, first we can write second element, S to R, S of R. But if it is a relation, we are writing the same way, R of S. R of S is equal to, that is a composition of a relation, right? So similar, you have a three sets A, B, C, right? So it means what will happen in the relation R, the range B considered as a domain for the relation S. So the first relation, the range considered as a domain for the second relation, right? So the composition of a relation, we can write R of S, right? Let's say A contain elements A, B, C. So B contain elements X, Y, Z, right? Then C contain elements 1, 2, 3, right? So there is a relation A cross B means by using these two, you have a relation that is we can call R, right? Also, you are creating a relation between B and C, right? So this is a relation S, right? R of S, that is the composition of R of S. That is a relation between A cross C, right? This is a relation between A cross C. So they are explaining these things, right? Yeah. So similar to the composition of a functions, right? Now I will explain with an example, right? Then you can easily understand. Right? So just look at here. A is a set with four elements. B is a set with four elements. C is a set with three elements, right? Now they are telling two relations. R is a one relation, S is a another relation. So easiest way you can draw a diagram, right? If you draw a diagram, you don't need to worry about, right? So now I am writing a relation from A to B. First, I am writing a relation from A to B, right? So A contain four elements, one, two, 3, 4. These are the elements of set A. Similarly, this is set A, this is set B. Set B contain four elements A, B, C, D. Right? Now I need to find out the relation, right? The relation R means that is a relation from R. R is a relation from A to B, right? So R is a subset of A cross B, right? So now the first element they are telling 1 comma A. So 1 comma A, this one. Second element 2 comma D, this one. Third element 3 comma A, this one. Fourth element 3 comma B, this one. Fifth element 3 comma D, right? This is the relation R, right? Similarly, now they are telling another relation S. That relation S is a subset of B cross C. Now I need to find out the elements of B. So B contain three elements X, Y, Z. The set C contain three elements X, Y, Z. Now what I need to do? The second relation S. First pair ordered pair is B to X. So B to X. This one. Second ordered pair B to Z. Third ordered pair C to Y. Fourth ordered pair D to Z. Right? So now I can write I can draw the diagram for relation R and S. Now I need to find out R of S, right? Now I need to find out R of S. R of S means I need to find out some ordered pairs of R of S. That is a composition relation. So this is a relation. This is a relation on R, right? This is a relation on S. Similarly, I need to find out the relation of R of S. It means that is also we need to find out which elements comes, which ordered pairs come for the relation R of S. We don't know how many, maybe we don't know exactly how many comes, right? Now we need to find out ordered pairs for R of S. How to find out these ordered pairs of R of S? For that one, we know that R of S means that is a relation. R of S is a relation. That is a subset of A cross C, right? Did you get my point? So this is A cross B, this is B cross C. The R of S is a relation. Definitely that is a subset of A cross C. So this is A. So A to B. So the B in the relation R, B is the range. Now in the relation S, B is the domain, right? Now R of S, definitely it will come is a subset of A cross C, right? So one way you can write A cross C, right? So A contain four elements, B, C, this is C, right? So A contain four elements, C contain three elements. So 4 into 3, 12 ordered pairs are coming. 12 ordered pairs are coming for A cross C, right? If I write A cross C, what will happen? So A contain 1x, 1y, 1z. Similarly, 2x, 2y, 2z. Similarly, 3x, 3y, 3z. Similarly, 4x, 4y, 4z. Right? These are the all 12 ordered pairs of A cross C. Right? Among these all 12 ordered pairs, we need to find out only suitable ordered pairs for this relation. How you can find out only the suitable ordered pairs? For find out that one, first you need to take the first element in A, right? This is first element is 1 is the element from A. Now we need to find out, is there any possibilities from here to move to here? Is there any possibilities from the element A to element from the set A to C? You need to find out, is there any possibilities to move from A to, is there any possibilities you can move from A to C, right? if you have a possibility, then that is considered as a one pair of this relation, right? So if you look at one here, we can move for B. One to A, there is a relation, but from A, there is no any arrows to move for C, right? So there is nothing with one, right? Then I can take the second element 2, right? If I take the second element, from this element, I can move for B, right? So I now in D, also from D, I can move to C, right? Then I need to tell 2 and Z are one ordered pair. 2 and Z are one ordered pair in the relation R of S, right? Again, I need to check the third element. So third element, right? Maybe there are two arrows. Maybe if I move for A, I can't move to from A to C. So from here to here, I can move, right? There is an arrow, but from this point, I can't move for the my set C. So I can do this way. Then if I take the second direction, then I'm in B. From B, I can move for X, right? This is one option. So one pair is 3 comma, one pair is 3 comma X. Also another pair is there, right? What is the next pair? Next pair from 3 to B, then I move to Z as well, right? So my second pair, 3 comma Z. Now if I take 4, from 4 I can't move there is any places. So these are the three ordered pairs for the composition relation R of S, right? The easiest way you can draw the diagram, then you can check is there any possibilities I can move from A to C. It means is there any arrows, arrow marks? Throughout the arrow marks only I can move, right? So if I take 1 here, from 1 I can't move from 1 I can move to A, but from A I can't move to another places, right? So there is no any ordered pair for from 1. If I take 2 here, from 2 I can move to D, from D to Z. So 2 and Z are 2 and Z are one ordered pairs in the relation, composition relation R of S. Similarly, from 3 there are two ways. This way, one way, only this way, right? But if I move this way, I can't move, right? So then likewise, you can find out the composition relation, right? So these are the things I will explain these, right? So just you can read those things and you can easily understand, right? So, so if you look at here, R of S, they are already mentioning, right? 2 and Z, 3 and X, and 3 and Z. So this is the way we can find out the element of a composition, right? Is you need to check is the direction from A to C by using the arrow mark, right? You need to check that one. Okay. So this theorem you can apply not only for two relations, right? It means just you have a relation R of S of T. It is also equal to, okay, this is also more than one. It also possible, right? S of T. Not only two, maybe more than two composition relation, you can apply this theorem, right? That is explained by this point, right? Now we will move for the last part of the theory, types of relations, right? Now we will look at types of relations. Okay. Uh, Only here we have three types of relations, right? Uh, that's all. Okay. Now we will move for the types of relation, right? The first type of relation, reflexive relation, right? The first type of relation we can call reflexive relation. Reflexive relation means you need to remember what do you mean by reflexive relation. Okay. I will explain what is reflexive relation, right? Just think about uh, yeah, you have a set A, right? Just think about you have a set A, maybe which have some number of elements, right? Now, reflexive relation means, okay, now there is a relation, right, from A to A, right? The set A itself have some relation, right? A set A it has a relation itself. Itself set A has a relation, right? So A cross A, the A cross A is a subset of this relation, right? So this relation consider as a reflexive relation when all the elements in the set A, all the elements, every element, not one or two elements, right? The important point here, every element, every ordered pairs, every element in A. Let's say A have four elements, 1, 2, 3, and 4. These are the elements of set A. Then set A has a relation itself. Set A has a relation itself, right? Reflexive relation means A comma A is belongs to the relation R, right? The important thing, every element in the set, every element in the set A have these condition, right? So then only you can tell that is a reflexive relation, right? So now the set A contain four elements. 1, 2, 3, 4 are the elements of set A, right? Now they are telling A has a relation on itself, right? Can you tell me the relation R that is a reflexive relation, right? Now if I ask you to write the reflexive relation for this A, so how many elements come? How many ordered pairs you need to write for this reflexive relation? Tell me. Tell me. How many ordered pair are you right? So reflexive relation means you need to satisfy these conditions, right? So the ordered pair A comma A belongs to the relation. The important thing, every element in the set A satisfied this condition. Then only we can say that is a reflexive relation. Did you get my point? So what are the ordered pairs you can write for this relation as a reflexive relation? Tell me. So reflexive relation means your ordered pairs are same. A comma A is your ordered pair, right? So your first element and the second element. So first element from A, second element also from A here, right? Then your ordered pair is A comma A. It means same elements for both. Both in the ordered pair, both elements are same elements. But the important thing here, for or every element in the set, right? So what are the ordered pairs you need to write here? Hmm? So this relation R, let's say this relation R, if the relation R is a reflexive relation, it must be 1 comma 1, 2 comma 2, 3 comma 3, then 4 comma 4, right? If your relation contain all these four elements, then only you can say this relation R is a reflexive relation, right? Okay, now tell me there is another relation R1, right? It contains 1 comma 1, 1 comma 2, right? 2 comma 2, 2 comma 3, 3 comma 3, 4 comma 4. Now tell me whether this relation is reflexive or not. Hmm? So if a relation is a reflexive relation, all the elements of set A, not all the elements in the relation, right? All the elements in the set A is the set. All the elements in the set A definitely have this condition, right? All the elements in set A have the ordered pair, same ordered pair, right? Here the set A contains four elements. So what about this R1? R1 is a reflexive or not? What do you think? Tell me. R1 is a reflexive or not, depending on your understanding. Tell me. R1 is what? R1 is R1 is R1 is reflexive, right? Why I am telling R1 is reflexive, right? Maybe in that relation, whatever the elements, whatever the ordered pair they have, right? But the important thing, if a relation is a reflexive or not, you need to check. First, you need to check what are the elements are coming for the set. So in the set A, only four elements, 1 to 4, right? So if the set have four elements, 1 to 4, within that relation, definitely they have 1, comma 1, 2, comma 2, 3, comma 3, 4, comma 4. Definitely these four pairs must included in this relation. Maybe you have more than other ordered pairs, right? First, you need to check is this available all these four ordered pairs. If these four ordered pairs are available, you don't need to worry about what are the other ordered pairs in that relation. We can say this relation R1 is reflexive, right? This relation is a reflexive relation. So that is the condition, right? Did you get my point? You have a set, on that set how many elements, then definitely all the elements of that particular set included as a ordered pair, same set, same ordered pair, right? Even you have more than that, it's no worries, right? So you need to check if you have a set A with four elements, 1, 2, 3, and 4, definitely 1, 1, 2, 2, 3, 3, 4, 4 must be there in the relation. If these four ordered pairs in a relation, then you can say that relation is a reflexive. Now tell me, R2 is a relation 1, 1, 1, 2, 2, 2, 3, 3, 3, 4. What do you think about now? What do you think about relation R2? What do you mean by R2? Hmm? R2 is not reflexive. Very good. Why not reflexive? Because in the relation R2, 4, comma 4 is missing, right? 4, comma 4 is missing. Because of that, we can say R2 is not a reflexive relation. Okay. So a relation is a reflexive. Definitely, you need to contain all the ordered pairs of the same orders, right? Now tell me, right? This is one example, right? Now I will give another example similar to this one. Okay. Okay. Now, right, there is a set A. Set A contain three elements X, Y, Z, right? Now they are telling a set A. Now they are telling A itself create a relation. A itself create a relation, right? It means the relation is a subset of A cross A, right? So this is the meaning. A itself create a relation, right? Now I am writing a relation R1, right? XY, XX, YY, YZ, ZZ. What do you think? R1 is a reflexive or not? R1 is a reflexive or not? R1 is what? What about others? R1 is reflexive. Why I am telling R1 is reflexive, right? Now the set A contain three elements X, Y, and Z, right? So to become a reflexive, so this any relation we are creating by using A is a reflexive. Definitely they have these three elements, right? XX, YY, ZZ, right? If you have these three elements, if you have these all three elements, then that relation is a reflexive. If you're missing any of these, we can say this is not a reflexive. That is important, right? So I think you are familiar with these, right? So whatever the relation, if you are creating that relation include these three elements, then you can say that is a reflexive, right? If let's say now I am creating a relation R1, right? XX, YY, then XY. So this is not reflexive, right? So here ZZ is missing, right? If it is a reflexive, all the elements of A definitely they have these the same element. Then only we can say that is a reflexive relation, right? So now you are clear with reflexive, right? So this is they are explaining relation R on a set A is reflexive. They are telling this way, right? So previously I am telling A comma A is an element of A comma A is an element of R. Similarly, B comma B is an element of R. C comma C is element of R. Let's say A is a set with, let's say now A is a set with A comma B comma C. Then C comma C is a relation of R. Then if you satisfy these three conditions, then only we can say this is a reflexive. Or we can write this one. Maybe we can write this one. A related to A. Similarly, B related to B. Similarly, C related to C. Right? They are explaining that way. Right? Both are same. Right? So A related to A for every A in set A, right? Not only one or two, for every element in a set A, definitely they need to satisfy this condition. Then only it becomes true, right? So what will happen? Let's say A is with three elements, A, B, C. If you're missing, let's say there is a relation R, it contains A comma A and B comma B, right? There is no C comma C, right? So now this is not reflexive, right? This relation R is not reflexive. Why it is not reflexive? Right here, C comma C is not an C comma C not belongs to the relation. Because of that, we can say this is not a reflexive, right? Okay. Now we are giving some example. There are five relations, right? Just tell me one by one. Okay. They are giving five relations, right? Tell me. Okay. Okay, for these five questions, okay, these five questions, they are giving a set A with 1, comma 2, comma 3, comma 4, right? So now tell me, what about relation R1, right? How you need to check for the reflection? For the reflection, so the set A contain 1, 2, 3, 4, then definitely in the relation R1, you need to check 1, 1, 2, 2, 3, 3, 4, 4 is available or not. 1, 1 is there. 4 is there, right? But 2 2 and 3 3 is missing. So R1 is not reflexive, not reflexive. Similarly, R2 1 1 is there, 2 2 is there, 3 3 is there, 4 4 is there. So this is reflexive. How about R3? R3, there is no 1 1 2 2 3 3 4 4, right? So this is not reflexive, right? How about R4? R4, R4, there is no any elements, right? It's an empty set, empty relation. So empty set means there is no any ordered pair. So that is not reflexive. So if it is a reflexive, definitely you need 1, 1, 2, 2, 3, 3, 4, 4 in there. If you have these four ordered pairs, then only we can say that is a reflexive. How about R5? R5 is what? A cross A, the universal relation. So universal relation means by using this set, we are writing all the possible elements. So altogether, 16 ordered pairs in the A cross A, in the universal relation. So how about R5? R5, it is a reflexive. Why? If I write A cross A means I can write all the possible combination of ordered pairs, right? So definitely they have 1, 1, 2, 2, 3, 3, and 4, 4. So these R2 and R5 are only reflexive. The remaining are not reflexive. Any questions? Any questions? Any questions? Okay. Now if we will look at another second type, right? First type is a reflexive. Second type is a symmetric, right? Symmetric relation, right? So the symmetric relations means you know what is symmetric? Symmetric in the sense, right? If you have a circle, right? If you have a circle, if it is a symmetric means you can divide into equal parts, right? That is we can call symmetric. It's not symmetric, right? Symmetric means you are dividing into equal part, right? So the symmetric relations in the sense, let's say the same example, you have a set A with n number of elements. So there is a relation with set A itself. So it's a subset of A cross A, right? So the symmetric in the sense, in that relation R, you have a pair. A comma B is one ordered pair in the relation. Then definitely it must have B comma A also is a relation. Then we can say this is a symmetric relation, right? Now, just imagine you have a relation, right? Relation means you have creating ordered pairs, right? In that ordered pairs, if you have a pair A comma B, if you have a pair, definitely B comma A also included on that relation. Then we can say that relation is a symmetric relation, right? So if you have a ordered pair A comma B in your relation, definitely you need the ordered pair B comma A also in the relation. Then we can say that relation is a symmetric relation. It means A comma B is a relation. Definitely B comma A also included in the relation. Right? It means not every right. Not here. Just think about this way. Right? Okay, I will explain this way. Right? A contain three elements, A, B, and C, right? So the relation R, okay, R1 is a relation, is a subset of A cross A, right? Now I am writing R1, right? R1, right? The ordered pairs, A comma B, one ordered pairs, A comma C is another ordered pair, right? A comma A is an ordered pair, right? B comma A is another ordered pair, right? Now this is my relation R1. Now tell me whether R1 is symmetric or not. What do you think? So R1 is a relation with four ordered pairs, right? Now tell me whether R1 is a symmetric or not. How you can check symmetric or not? How to check symmetric or not? Tell me how to check symmetric or not. So symmetric or not means you can check that first ordered pair A comma B. If you have this ordered pair, definitely you need an ordered pair B comma A in the relation, right? So here the first ordered pair is A comma B. Now you need to check is there any B comma A is also available in this. So B comma A also there, right? So now it's correct. Now you need to check the second pair, A comma C is your second ordered pair. Now you need to check is there any C comma A in the ordered pair. But there is no C comma A in the ordered pair. So because of that, you can say R1 is not symmetric. Did you understand? Now if you look at the third one, A comma A, so so the A comma A, the opposite is also A comma A, right? So you don't need to worry about the same element because that is the same, right? So A comma A, both sides are same, right? Similarly, if you look at B comma A, then the opposite is A comma B. So A comma B is there, right? So this relation is not symmetric. Why we are? What is the reason for that one? Here we have A comma C is a belongs to the relation R1, but C comma A is not belongs to R1. Because of that, we can say this is not a symmetric. Right? Understand? Understand? So you need to check each ordered pair by ordered pair, right? First ordered pair, you need to check if they have any opposite. A comma B means B comma A also there. You need to check. If they all the elements have that way, we can say that is a symmetric, right? Okay, just there are very small things, right? I try to finish the relation, then only we can move for the next part by next class, right? Okay, now we will look at the same example, right? Okay, yeah, okay. Uh, Now we will check with the same example, relation R1 to R5. Now tell me what do you mean, tell me with R1, what is that? Tell me, R1 is a symmetric or not? How to find out? R1 is symmetric or not? How to find out? Tell me, R1 is symmetric or not? So first order pair is 1 comma 1, right? So it definitely A comma B and B comma A are same. A comma B and B comma A are same for the same element, right? This is correct. So now we need to check. So similarly, for all the same element set, we don't need to worry about that one, right? So now here the second one, 1 comma 2 is there, right? We need to check 2 comma 1 is there, but here 2 comma 1 is not. So R1 is not symmetric, right? Then you don't need to check others, right? How about R2? How about R2? So R2, so 1, 1, we don't need to check, right? 2, 2, we don't need to check. 3, 3, we don't need to check. 4, 4, we don't need to check. So here 1, 1 is there. So 2, 1 also there, right? Here 2, 1, 1, 1 also there, right? So R2 is symmetric. How about third one? Third one here, 1, 3 is there, but 3, 1 is not there. 2, 1 is there. 1, 2 is there. So R3 is not symmetric. This is symmetric. R3 is not symmetric. R4, R4, that is not symmetric. R5, that is definitely a symmetric, right? R5 is symmetric. Why? We are writing all the possibilities with the elements, right? So definitely it have a symmetric, right? So now if you look at here, R1 is not symmetric. R3 is not symmetric, right? Uh, yeah, R4 is an empty set, no? So that is a symmetric, right? There is no elements, right? So that is also considered symmetric, right? Empty set. The last one also empty set, right? Now this is symmetric, right? The next one, anti-symmetric, right? So not symmetric means that let's say you have a comma B belongs to R, B comma A is not belongs to R, then we can say this is not symmetric, right? So anti-symmetric is different, right? There is there is no similar meaning for not symmetric and anti-symmetric, right? So anti-symmetric is a different idea, right? I will explain that one, right? So anti-symmetric means, okay, yeah, this one we discuss, continue, right? So the anti-symmetric means A comma B belongs to R and B comma A belongs to R, right? Antisymmetric means because of A is equal to B only. Only A is equal to B, only there A comma B belongs to R, B comma A belongs to R. Then this is antisymmetric, right? Did you get my point? So previous case, A comma B belongs to R. If you find all the elements for B comma A also belongs to R, then that is a symmetric, right? Antisymmetric means because of A is equal to B only, you are satisfying these condition. What do you did you understand? If A is equal to B means that is 1 comma 1, right? A is equal to B means the same elements, right? Because of this one only, you are achieving A comma B belongs to R. Also B comma A belongs to R. That is antisymmetric, right? So A comma B belongs to R. B comma A belongs to R. Because of A is equal to B, then we can say that is antisymmetric. It means It means if A is not equal to B, if A is not equal to B, then it is not true. A comma B belongs to R, then B comma A not belongs to R. It will happen, right? A is not equal to B, then it will happen, right? That is antisymmetric. I will explain with an example, then you can easily understand, right? Now you are clear with reflexive and symmetric, right? Antisymmetric is little bit different idea, right? Okay, just look at here. You have a set A with 4 elements, 1, 2, 3, and 4, right? Now, there is a relation, is a subset of A cross A, right? Now, I am writing a relation R1. It contains 1, comma 1, 2, comma 1, right? This is one relation, 1, comma 1, another relation, 2, comma 1. Okay, now there is another relation 1 comma 2, right? Now tell me whether it's a symmetric or not. This is symmetric. Why? First element, that is also a comma b, b comma a also there. 2 comma 1. So the opposite form 1 comma 2 is there. So this is symmetric. So R1 is symmetric, right? Now we need to look at whether it is a antisymmetric or not. So this is not antisymmetric. This is not antisymmetric. This is not antisymmetric. Why I am telling this is not antisymmetric? So it antisymmetric means, so the a comma b and b comma a comes only because of a is equal to b, right? So it means here what will happen, 1 comma 1 is there, right? So a comma b and b comma a are same. A comma b and b comma a, 1 comma 1, 1 comma 1 is there, right? It is swapping also same because of a is equal to b, right? A is equal to 1, a is equal to 1, b also equal to 1. Because of that, this happen, right? A comma b and b comma a. If you look at here, 2 comma 1, right? The swap opposite form is 1 comma 2, right? This happen only because of a is equal to b, but a is equal to 2, b is equal to 1. So 2 is not equal to 1, right? But they have two opposite forms. So because of that, this is not antisymmetric, right? When it will become a antisymmetric? To become an antisymmetric, if you remove this element, is considered as a antisymmetric. Now just think about here, 1 comma 1 is a 1 comma 1 have two forms, right? A comma b and b comma a, both are same because of a is equal to b. Here what will happen? 2 comma 1 is there, 2 comma 1 is there, right? The opposite form is 1 comma 2. This is not available in the relation. So this happen, the symmetric thing, swap thing happen only because of a is equal to b. Then we can say relation R1 is anti-symmetric. This is anti-symmetric. You get my point? So symmetric means a comma b and b comma a, two ordered pairs are available for all the ordered pairs in the relation, right? If it is an anti-symmetric, a comma b and b comma a, the ordered pair, swept ordered pair and the swept ordered pairs are available because of a is equal to b. So a is equal to b means same order, same element ordered pairs are only available, then we can say that is a antisymmetric, right? Now I'm writing another relation. Tell me 1 comma 2, right? 2 comma 1, right? 1 comma 3, 3 comma 3, right? Now what do you think? Whether it's antisymmetric or not antisymmetric? Hmm? What do you think? Tell me about R2. R2, what do you think? This is not antisymmetric, right? This is not antisymmetric. Why? I already told you, right? If you have 1 comma 2, it not be 2 comma 1 is available, right? If 2 comma 1 is available, this is not antisymmetric, right? If I remove this one, now this is antisymmetric. Why? Here 1 comma 2 is there, but there is no 2 comma 1. There is no, here the next element is 1 comma 3, but there is no 3 comma 1. Only here 3 comma 3 is there, right? So the swept form also 3 comma 3. So this is antisymmetric because there is no opposite side of this 1 comma 2 and 1 comma 3 is not available. Because of that, we can say this is antisymmetric by a comma b and b comma a belongs to R because of a is equal to b only. Only because of a is equal to b, it will happen. Then only we can say that is an antisymmetric. Okay, now we will look at for antisymmetric as well for all the things, all the 5 relation. We will look at one by one, right? Only there, the last portion is there, right? Okay. Now just look at one by one, right? So if you look at the first one, relation R1, what do you think about whether it's antisymmetric or not? So now 1 comma 1 is there. The swap form also 1 comma 1, right? It's correct, right? Here 1 comma 2 is there. Now we need to check, we need to verify 2 comma 1 is not there, right? If 2 comma 1 is there, this is not antisymmetric, right? Here, if you look at the second element, 2 comma 1 is not there, right? So now it's also correct form, correct way. 2 comma 3. Now we need to check 3 comma 2 is there. So 3 comma 2 is also not there, right? This is also correct. Here 1 comma 3 is there, 3 comma 1 is not there, right? Then the last one 4 comma 4 is there. So this is a comma b and b comma a in the same form because of a is equal to b. So these two pairs are only satisfy these. So because of that, R1 is a antisymmetric. R1 is antisymmetric, right? So if you look at R2, 1 1 is there, 2 2 is there, 3 3 is there, 4 4 is there. But if you look at here in the R2, 1 2 is one ordered pair. 2 1 also is a swept version, right? So it is in the form of a comma b and b comma a. But these two things are happen only because of a is equal to b. Then only it is antisymmetric, right? But here without a is equal to b, because 1 is not equal to 2, no. So because of a is equal to b, they have symmetric. Then we can say R2 is not antisymmetric. So R2 is not not antisymmetric, right? This is antisymmetric R1. R2 is not antisymmetric. If you look at the R3 here, this is not antisymmetric, right? Why? There is no 1 1 or 2 2 or 3 3 or 4 4. Because of that, R3 is not antisymmetric. R4 R4 is also not antisymmetric. R5 R5 is not antisymmetric. Why? R5 is a universal relation, right? Definitely, if we have A comma B, definitely B comma A also they are in for each and every elements, right? So R5 is also not antisymmetric. So only R1 is antisymmetric. If you look at here, so R1 is, yeah, this one. R1 is not antisymmetric, right? They are telling this reason, right? R3 is not antisymmetric. All others are antisymmetric, right? Yeah, the R4 is an empty set, right? So they are telling that is a antisymmetric because there is no any elements. Okay, this is wrong, right? I think, yeah. Yeah, this is antisymmetric. So R2 is not antisymmetric. R3 is not antisymmetric. R4, R5 also antisymmetric, not antisymmetric, right? There's a small mistake here. R4 is an empty set, no. So there is no any elements, right? So R5 is not antisymmetric. Why? R5 is not antisymmetric, I'm telling here. So we have a set pair is 1 comma 1, right? 1 comma 2 is there. Also 1 comma 3 is there. 1 comma 4 is there. Then similarly 2 comma 1 is there. 2 comma 2 is there. So here 1 comma 2 and 2 comma 1 also there, right? So it means without 1 is not equal to 2, right? It means it is not a antisymmetric, right? So there is a small mistake in the sentence, right? I will correct and send it to you, right? Here R1 only antisymmetric, R2 is not antisymmetric, R3 is not antisymmetric, R4 is not antisymmetric, R5 also not antisymmetric, right? The last part, uh, yeah, just you can read this sentence, right? There is nothing, right? They are telling symmetric and antisymmetric is not symmetric is not negative part of antisymmetric, right? So that is totally different. They are telling here, right? So if you look at here, the relation R is this is it symmetric? It is not symmetric. Why it is not symmetric? 1 3 3 1 is there, but 2 3 3 2 is not there. Because of that, it is not symmetric. If you look at the anti-symmetric, there is no 1 1 or 2 2 or 3 3 or 4 4. So because of that, so if you have 2 comma 3 and 3 comma 2, then what will happen? This is not anti-symmetric, right? So this is not anti-symmetric. If you look at this one, this is symmetric as well as this is anti-symmetric, right? By A comma B and B comma A happen because of A is equal to B only, right? Then that is anti-symmetric and symmetric, right? So they are telling symmetric is not negative form of anti-symmetric, right? They are two different concepts, right? Don't compare symmetric and anti-symmetric are opposite things, right? So symmetric means you can check A comma B belongs to R and B comma A belongs to R. If it is anti-symmetric, A comma B belongs to R and B comma A belongs to R only because of A is equal to B. Then only that is anti-symmetric. The last one, transitive relation, right? So the transitive relation means, right? Okay, transitive relation means you have a order, you have, let's say you have a set A with set number of elements, right? There is a relation R, right? There is a relation, okay, there is a relation R is a subset of A cross A, right? Transitive means you have an ordered pair A comma B belongs to R. Similarly, you have an ordered pair B comma C belongs to R. Then definitely you have an ordered pair A comma C also belongs to R. If you satisfy this condition, then we can say this is a transitive relation, right? So in your relation, already you have a ordered pair A comma B. You have another ordered pair B comma C. Also, if you have A comma B and B comma C, if you have A comma C also, then you can say this relation is a transitive relation, right? A comma B, then B comma C. Also, you have A comma C also a ordered pair in the relation. Then we can say that is a transitive relation, right? So let's look at here. A comma B is a relation, B comma C is a relation. Then if you have A comma C also in the ordered pair in your relation, then we can say that relation is a transitive relation, right? We will look at with the same example, right? If you go through the same example, right? So how about R1? So R1 contain 1 comma 1, right? So this is one ordered pair. 1 comma 1 is an ordered pair. Another ordered pair, 1 comma 2 is an ordered pair. Then if you take the first element and the last element, then definitely you must have a 1 comma 2 as an ordered pair, right? That is available, right? Now if you look at here, 1 comma 2 and 2 comma 3, right? One ordered pair is 1 comma 2, another ordered pair 2 comma 3. Then you have another ordered pair 1 comma 3. So 1 comma 3 also exists, right? So now it's fine, right? So if you have at least one that type of things, then you can say that relation is a, if you have that type of things, you can say R1 is a transitive, right? Now, similarly, you can look at this one. Is there anything available? No, right? If you have A comma B is belongs to R, and if you have B comma C also belongs to R, then definitely if you have A comma C also belongs to R, then you can say this relation is a transitive relation, right? So R1 is a transitive. R1 is a transitive. Now, if you look at the second one, 1 comma 1 is there, 1 comma 2 is there. So 1 comma 2 1 comma 2 is also there, right? If you look at here, 1 comma 2, 2 comma 1, then 1 comma 1 is there, right? So that is all correct. So if you look at here, yeah, here we can write 2 comma 2 is there, then 2 comma 2 is there, then 2 comma 1 is there, then we need a 2 comma 1. So 2 comma 1 also there. So R2 also a transitive relation, right? If you look at here, these two pairs, right? 2 comma 1 is one pair, another pair 1 comma 3 is another pair. So here you don't have any ordered pair 2 comma 3, right? You don't have any ordered pair 2 comma 3. So because of that, you can say R3 is not transitive, right? Similarly, R4 is not transitive. R5 is transitive, right? R5 is a universal set, no? So R5 is transitive. R4 is not transitive, right? So R3 is not transitive, right? Why? They are giving an explanation. So R5, R1, R2 are transitive, right? Empty set, you don't need to worry about, right? So if you have an empty relation, that is not transitive or that is not symmetric or that is not anti-symmetric, right? You don't need to anything, right? Okay, that's all. These are the three different types of relations, right? Reflexive, symmetric, anti-symmetric, and transitive, right? These are the four different types of relations, right? Okay. Okay. The last part, right? Equivalent relation, right? Equivalent relations mean if any relation is reflexive, any relation is reflexive as well as symmetric as well as transitive, then we can say that is a equivalent relation, right? So if I ask you to prove that relation is equivalent relation, first you need to prove that relation is a reflexive, that relation is a symmetric, that relation is a transitive. If a relation satisfies these three relations, then we can say that is a equivalent relation, right? So if I ask, normally I will ask this type of question for your final exams, right? Prove that the relation is a equivalent relation, right? For that proof, you need to prove the relation is a reflexive relation, right? Reflexive means A comma A, right? Also, you need to prove that relation is symmetric, A comma B and B comma A, right? That is symmetric. Also, you need to prove that relation is a transitive, A comma B is a belongs to R, B comma C belongs to R, then A comma C also belongs to R, that is a transitive. So if you prove these three relations, reflexive, symmetric, and transitive, then we can say that relation is equivalent relations, right? That's all. So that's all the theoretical things, right? So yeah, I will try to explain with some one or two questions, then we will wind up the session, right? Then you can practice with the remaining part, right? First, I will tell you, right? Okay. Okay, just yeah, we will look at this example, right? They are giving a question, relation R. They are giving a relation R, right, on set S. There is a set S with three elements, 1, comma 2, comma 3 are the three elements. Now they are giving a relation R, right? Now they are telling you, you need to prove this is an equivalent relation or not. This is the final question, right? I am giving a set and I am giving a relation. I am asking you, this relation is equivalent relation or not, right? I'm asking you, prove that. I'm asking you, prove that this relation is equivalent relations or not, right? I need to prove whether it's a relation is equivalent or not, right? How you can prove this one? First thing, you need to prove whether it's a reflexive or not. How you can prove whether it's a reflexive or not? So how you can prove whether reflexive or not? So the theory says, if you have a set S with three elements, right? To become a reflexive, definitely you have 1 comma 1, 2 comma 2, 3 comma 3 in your relation. If you have these three elements, three ordered pairs in your relation, then we can say that is a reflexive relation. Right now, just look at here. 1 comma 1 is there, 2 comma 2 is there, 3 comma 3 is there. So all the three pairs are exist in the relation. Then we can say R is reflexive relation, right? Did you get my point? Now we need to prove symmetric or not. Now how you can prove this relation is symmetric or not? So to check the symmetric or not, if you have A comma B is belongs to R, then also B comma A also belongs to R. Now you need to check for all the pairs, right? So 1 comma 1 we don't need to check. 2 comma 2 we don't need to check. 3 comma 3 we don't need to check. So only you need to check for 1 comma 2. So 1 comma 2 the swap version is 2 comma 1. So this is also there, right? So then we can say 1 comma 2 and 2 comma 1 also belongs to the R. So this is a symmetric. So we can say this is a symmetric relation, right? The third one, we need to prove transitive or not. How you can prove transitive or not? How you can prove transitive or not? So A comma B and B comma C is there, then A comma C also there, right? Here, 1 comma 1, 1 comma 1, and 1 comma 2 is there. Then we need 1 comma 2, right? First element from A, last element from B, right? So 1 comma 2 also there, right? So first one is okay. Now if you look at the second one, so 1 comma 2, 2 comma 2, then the transitive element is 1 comma 1. So 1 comma 1 also there, right? The next one, the next one, this one, right? Just look at here, this 1 comma 2 and 2 comma 3, right? Here what will happen? 1 comma 2 we need, right? 1 comma 2 already this one, so that is also there, right? So this function also a transitive function because all A comma B and B comma B and A comma C also, A comma B and B comma A and A comma C also belongs to R. Because of that, we can say this is a transitive relation. So this is a reflexive, symmetric, and transitive. Then we can say this relation is a equivalent relation, right? That is the way we can prove these type of questions, right? Any questions? Any questions? Any questions? Okay, yeah, I will explain the first question, right? Now they are giving three sets. A is a set, B is a set, 3 is a set, right? Now we need to find out the A cross B cross C, right? So how many ordered pairs are coming? So this is not a binary ordered pairs, right? So the cross product is 3 elements. So here, how many? Here number of A is equal to 2, 2 into 3 into 2. So altogether 12 ordered pairs, right? So what are the ordered pairs? So first you can take the first element from A, right? First element from A, then first element from B, first element from C, right? Then first element from A, first element from B, second element from C, right? Then 1 comma, sorry, 1 comma X comma 3, 1 comma X comma 4, then 1 comma Y comma 3, then 1 comma Y comma 4, then 1 comma Z comma 3, then 1 comma Z comma 4. Likewise, you can draw altogether 12, 1, 2, 3, altogether 12 ordered pairs, right? This is they are asking as a question, right? So you need to find out A cross B cross C, right? This is not a binary relation, right? This is a ternary ordered pairs, right? So you know how to find out the answer for this type of question, right? So the next thing, right? They will ask, right? X and find X and Y, right? So there are, we already know A comma B is a ordered pair is equal to C comma D when A is equal to C and B is equal to D. Then only we it's true, right? Second question, right? We know they are giving two ordered pairs, right? 2x and x plus y is one ordered pair. Another ordered pair, 6 and 2, right? So if both ordered pairs are equal means we can directly say 2x is equal to 6. Similarly, x plus y is equal to 2, right? So x is equal to 6 by 2, x is equal to 3. So x plus y is equal to 2. Then we know x is equal to 3. So if I replace x here, 3 plus 2 is equal, 3 plus y is equal to 2. So y is equal to minus 1, right? So this way we can find out x and y, right? So this type of questions also possible to ask you, right? Okay, now the next part, right? This part just drawing the graph, right? Okay, find the number of relation from A to B, right? I think you know how to calculate, right? Number of elements in A multiple by number of elements into B. That is the number of ordered pairs in A cross B, right? If you need to find out total number of relations, then you need to get the to the power of 2 of these numbers, right? Number of A into number of B, we are getting a number, no? Then that number to the power of 2 is the total number of relations we can find out, right? So now they are giving R and ask R inverse, right? So just you can practice, right? These are very simple questions, right? Yeah. Okay, then I will explain this one, right? So there is a two sets, A and B and C. There are three sets, right? Right. They are giving a relation from R to S, right? So now just you can draw the diagram, right? So yeah, they already draw the diagram as well, right? So the first relation is from R is from A to B, 1 to B, right? Already there. Then 2 to A is there. Then 2 to C is there. So if you look at S, A, Y is there. Then B, X is there. Then C, Y is there. C, Z is there, right? So this is the diagram, right? Now we need to find out R of S. How we can find out R of S? That is also a ordered pairs, right? How we can find out? I already explained you. Can you find out the answer for this one? R of S. So from first take with this element, then it will go this way, right? Then I can write uh, 1 and X. 1 and X is a one ordered pair in R of S. Similarly, from 2 to Y. So 2 comma Y is one ordered pair. Then 2 comma Y is another ordered pair. 2 comma Y is another ordered pair. Another ordered pair. 2 comma Z is another ordered pair. So all together four ordered pairs in R of S, right? So it's easy for you, right? Just practice. Okay. I think, yeah. Okay. As a homework, just practice those things, right? If you have any doubts, you can contact me or we will discuss by next class, right? Okay.